Year 13 Pure Maths Revision Video 2. This video will cover 4 questions, one each on the topics of differentiation, integration, trigonometry and parametric equations. Some questions will be interlinked in terms of the requirements and the topics that they cover. So let's start with the first example. So we've been given the equation of a curve and we're required to find the equation of the tangent to the curve at a particular x value. So this question will require us to be able to differentiate this function. Now it is set up in the format of a quotient, which means we're going to use the quotient rule that tells us that dy by dx is equal to v times du by dx minus u times dv by dx all over v squared, where u is going to equal ln of x plus 2 and v is going to equal cos x. So differentiating du by dx is equal to 1 over x plus 2. dv by dx will equal negative sine x. Two standard pieces of differentiation there. Now, in the first part, when we differentiate u, we're effectively using the chain rule. We know that ln functions differentiate to reciprocals 1 over, so ln of x plus 2 will differentiate to 1 over x plus 2, but we must multiply by the derivative of the inner function. However, the inner function is x plus 2, which differentiates to just 1, so you're multiplying by 1, which doesn't cause any change. So du by dx is simply 1 over x plus 2. So we can now put together dy by dx, which is v times du by dx, so the product of these two. So that's cos x over x plus 2 minus the product of these two, so that's a minus minus, so that will be plus sine x ln x plus 2, and all of this is over v squared, which is cos squared x. I'm not going to try and simplify this because the question didn't actually ask me to find dy by dx in a simplified format. It wants the equation of the tangent to the curve. So let's be efficient. Let's not create additional work that we aren't required to do. We're not required to express the derivative in a particular format, so I'm not going to do that. I'm simply going to work out when x equals 0, I'm going to find the y coordinate by substituting into the equation here. So x equals 0, y is equal to ln of 2, and dy by dx we will find by substituting x equals 0 into this function here. Now cos of 0 is 1, so we end up with a half, plus now sine of 0 is 0, so this part just becomes 0, and in the denominator cos squared of 0 is just 1 as well, so dy by dx is equal to a half. We're then going to make use of the standard form of the equation of a straight line. Y minus y1 equals m bracket x minus x1. So y minus ln2 equals a half x minus 0. So this then gives us y equals a half x plus ln2. So the second example is an integration question. We've got to find this integral. We've actually been given some starting points here. We've been given the substitution. So we have to do this with integration by substitution. So what do we know? We know that u is equal to 3x plus 1. So du by dx is equal to 3. And then I can do a little bit of rearrangement here, which goes in quotation marks because, as we know, it's not real maths. So then substituting into the integral, let's leave this 18x alone here for the moment. And then this next piece, 3x plus 1 to the 7, well, that can be replaced by u to the power of 7. And then, of course, we need to replace dx, which we do like so. Now, we can simplify this. We can see 18 over 3 will simplify to give us a 6, which I'll pull outside the integral. I've then got 6x u to the power of 7 du. And of course, at the moment, I can't integrate this because there's a u here, there's an x here, which will cause me a problem. So what I need to do is go back to the fact that u equals 3x plus 1 and rearrange this so I can see that x is equal to u minus 1 over 3. And then I can replace x in the integral with u minus 1 over 3. And then we can simplify this by expanding the bracket and simplify. So the 6 over 3 will give me a 2 outside the integral. And then expanding this bracket, I will simply get u to the power of 8 minus u to the power of 7 with respect to u integrated. So this then becomes 2 u to the power of 9 over 9 minus 2 u to the power of 8 over 8 plus my constant of integration. I've also expanded by this 2, multiplied by this 2 at the front here. So we then need to replace u with what it is in terms of x, so this needs to be substituted back in. So we have 2/9 of 3x plus 1 to the power of 9 minus 1/4 of 3x plus 1 to the power of 8 plus c. Now, the question does not require us to do anything further with our answer here, but quite often there are situations where we are asked to fully factorise an answer, and this is something that people do sometimes seem to struggle with, even though it's actually not as difficult as you might think. So on the next page, we are going to look at how you would factorise this result here. So let's look at the common factors. We've got 3x plus 1 to the power 9, 3x plus 1 to the power 8. So 3x plus 1 all raised to the power 8 can come outside the brackets. We've then got 2/9 and 1/4 here. So I am going to take out the common factor that I can here, which is going to be 1 over 36. Looking at the product of, looking at the lowest common multiple of 9 and 4. Now, I then need to make sure that I have something here which will multiply back to give me 3x plus 1 to the power 9. So I definitely need a 3x plus 1. And then effectively I need to make sure I do 2/9 divided by 1 over 36. So I'm going to end up with a factor of 8 here. Now for the second portion, I just need to end up with 1/4, 3x plus 1 to the 8. I already have the 3x plus 1 to the 8, so I just need a 9 here. And then plus c outside. And then I just simplify the contents of the large square bracket, which simplifies to give me 24x minus 1, and then plus c at the end. And here is the factorised format of our answer. So our third example takes us to some trigonometry. And part 1 is a very standard question which requires us to start with a combination of cos and sine functions and rewrite this in the format of a single trigonometric function, in this case a cos function, making use of the compound angle formulae. We're also told that we're working in radians here as well, so really important to note all that information. So root 2 cos x minus sine x is being expressed in the format r cos x plus alpha. So that's r cos x cos alpha minus r sine x sine alpha. I've expanded cos x plus alpha using the double angle identity and of course multiplied both parts by r. Now let's compare coefficients on the left and the right hand side. Let's have a look at cos x on the left and cos x on the right. So we can see that all the multiples on both sides must be equivalent, as this is an identity. So root 2 has got to be the same as r cos alpha. Now, if we do the same with the sine x, we can ignore the negative because both sides contain a negative. Now, the coefficient here is 1 on the left-hand side, so we know that 1 is going to equal r sine alpha. And we have a pair of equations to deal with. Call this equation 1, and I'm going to call this equation 2. Now, I'm very simply going to do equation 2 divided by equation 1. So r sine alpha over r cos alpha equals 1 over root 2. So that tells me that tan alpha equals 1 over root 2. And then using inverse tan on the calculator, alpha equals 0.61547. And we'll round that to 615 radians to 3 significant figures. Now, there are lots of ways of finding r. We can simply substitute this value of alpha back into either equation and rearrange to find r, but do make sure you substitute in the full calculator accuracy by storing this value of alpha in a calculator memory so that you end up with the most accurate possible value for r. The other way to find r is, of course, to use the fact that if you square these results, they will add up to give you r squared. So root 2 squared plus 1 squared will equal r squared cos squared alpha plus r squared sine squared alpha, which is just, of course, r squared because cos squared alpha plus sine squared alpha equals 1. So this tells us that r squared is equal to 3, so r is equal to root 2. So I've run out of space at the bottom of my page here, but ultimately we have found that root 2 cos x minus sine x can be expressed in the form root 3 cos x plus 0.615 radians, where the angle has been rounded to 3 significant figures. So now on to part 2 of the question. We are given f of x, which clearly involves part of the work we did in the previous question. So f of x could be written in the format 5 over 2 plus root 3 cos x plus 0.615 radians. And we've got to find the minimum value of f of x, giving our answer in this format here. Now, there will be a temptation to try and differentiate because people see the wording here and think minimum value must differentiate, and the question could be done using differentiation, but actually that's a more complex route to a very simple answer. We want to try and minimise f of x. So because f of x is written in the format of a fraction, effectively, to minimise this result, we need to maximise the denominator, because if you're dividing by a larger amount, you end up with a smaller result. So we want to maximise the denominator, which is 2 plus root 3 cos x plus 0.615 radians. Now, how do we maximise this? Well, let's think about the maximum value of this part here. It's a cosine function, so its max value overall is equal to 1. It doesn't matter what the value of x is, cos of x plus 0.615 will always have a maximum value of 1. Now, that means that the maximum value of all of this is going to equal 2 plus root 3. So that tells us that the denominator, when it's equal to 2 plus root 3, gives us the maximum value of the denominator and the minimum value of f of x. So the min f of x is equal to 5 over 2 plus root 3. But of course, it's clear from the wording of the question that we need to rationalise the denominator. So we're going to multiply the numerator and the denominator both by 2 minus root 3. We'll see what this gives us. So we'll end up with 5 bracket 2 minus root 3, and in the denominator we will simply end up with 4 minus 3, which is just 1. So we end up with 10 minus 5 root 3, and it does ask us in the question, it does say a, b and c are integers to be determined, which means that we need to state the values of a, b and c. So a is clearly 10, b is negative 5, and c is equal to 3. So on to our final question, in which we are required to show detailed reasoning, so really clear working must be shown throughout this. We are given a curve with parametric equations in a trigonometric format. Find the coordinates of the point on the curve with the greatest y coordinate. So find the coordinates of the point on the curve with the greatest y coordinates. So there are different ways we can approach this. We could approach this using the concept of differentiation here to find the greatest y coordinate. We could find dy by d theta and then solve that equation to find the value of theta for which y has a maximum. But we can actually simplify our work quite considerably as well here. Look at the format of the equation for y. Y equals 2 plus sine theta. Now, sine theta takes a max value of 1, and at this point, y would then equal 2 plus 1, or 3. So we've got the maximum y value. We then need to find the value of x for which this maximum y value occurs, so we're going to go back to the fact that sine theta equals 1, which means theta equals pi by 2 for the domain of theta values that we are working with. X can then be calculated by substituting into this equation here for x, this parametric equation, so that's 7 cos pi by 2 plus 2 cos, and we want 2 lots of pi by 2, which is just pi. Now, cos pi by 2 is 0, cos pi is negative 1, so that gives us negative 2. So the coordinates of the point on the curve with the greatest y coordinate are negative 2, 3. It's likely to be some sort of point which is probably about here. Now, for part 2, we've got to determine the y-coordinates of the points where the curve crosses the y-axis. So the curve crosses the y-axis in 2 places. It crosses the y-axis here, and it crosses the y-axis here. Now, what's interesting about those points is at those points, x, of course, equals 0. So x equals 0, that means the whole equation for x, 7 cos theta plus 2 cos 2 theta equals 0. And we've got to solve this equation and find out the value of theta, and then find out the y-coordinates from that. Now, we should recognise this as a trigonometric equation, and we should recognise the fact that there are multiple identities for cos 2 theta, and the key identity here is the one that features cos theta as well. So cos 2 theta is equivalent to 2 cos squared theta minus 1. We need to substitute that in. So 7 cos theta plus, and we've got 2 lots of cos 2 theta. So we want 2 lots of 2 cos squared theta minus 1, and that equals 0. And I'm going to rearrange this now. So 7 cos theta plus 4 cos squared theta minus 2 equals 0. And we have an equation that's sort of in that format of a quadratic in disguise, which we can then factorise. So this is going to be 4 cos theta, and then we want plus 2 minus 1. And always check back in your head that you have actually factorised correctly. So this tells me that cos theta equals a quarter, and this part tells me that cos theta equals negative 2, which has no real roots. So there's nothing more we can do with that section there. Now, cos theta equals a quarter. We're not going to use arc cos or cos to the minus 1 because we will get a non-exact answer for theta here. It won't be a neat multiple of pi. And if we substitute back into the y equation, we're not going to get an exact format for the y coordinates, and the question's specified. If you go back and look at the wording, we want y in its exact form. So how do we find sine theta if we know what cos theta is? Well, there are multiple ways of doing this, but I think an easy way is to use the fact that cos squared theta plus sine squared theta is 1. So sine squared theta is 1 take away cos squared theta. So that gives us sine squared theta, in this example, as being equal to 15 over 16. So that tells us that sine theta equals plus or minus root 15 over 4, square rooting. Now, y is given by the parametric equation y equals 2 plus sine theta. So y is equal to 2 plus root 15 over 4, or y is equal to 2 minus root 15 over 4.